the value of p and q for which the function f of x is equals sine of p plus 1 x plus sine x upon q x, where x is less than 0, and q for x is equal to 0 is continuous, and root of x plus x square minus root x upon x raised to 3 by 2 for x greater than 0 are a p 1 by 2 q minus 3 by 2, p 5 by 2 q 1 by 2, c minus 3 by 2 q 1 by 2, or p 1 by 2 q is equal to 3 by 2. So from this we know f of 0 is equal to q, and we can say f of 0 plus is equal to limit of x tends to 0 plus 1 plus x raised to 1 by 2 minus 1 upon x. Now this equals limit of x tends to 0 positive 1 plus 1 by 2x plus so and so up to minus 1 upon x, which gives half. Now f of 0 on the negative side, limit gives us limit of x tends to 0 on the negative side, sine of p plus 1 x sine x by x, which is equal to limit of x tends to 0 on the negative side, cos of p plus 1 x into p plus 1 into 1 plus cos x, which gives us p plus 1 plus 1, that is p plus 2. So now we can write p plus 2 is equal to q, which is equal to 1 by 2. So therefore from this equation we can say p is equal to minus 3 by 2 and q is equal to 1 by 2, which is answer C. The function f of x equals x minus mod of x minus x square is a continuous at x is equal to 1, b discontinuous at x is equal to 1, c not defined at x is equal to 1, or d none of these. So first we'll write f of x is equal to x minus mod of x minus x square as given. Then we'll write all these four conditions. So that is x minus x plus x square, x minus x square is greater than 0, greater than equal to, giving us x into x minus 1 is less than equal to 0, or it could be equal to x square if 0 less than x and x less than equal to 1, and thirdly x plus x minus x square if x minus x square is less than 0, giving us x minus 1 greater than 0, and the last is equal to 2x minus x square for x is less than 0 or x is greater than 1. Now when x is greater than 1, let x is equal to 1 plus h. So therefore h tends to 0. Then the RHL would be f of 1 plus equals limit of x tends to h tends to 0 f of 1 minus h, which gives us limit of h tends to 0 1 minus h the whole square, which is 1. And we could also write f of 1 is equal to 1 square, which is 1, because f of x is equal to x square. So therefore we can write f of 1 plus is equal to f of 1 minus, which is equal to f of 1. Therefore, f of x is continuous at 1, which is option A. If f of x is equal to x plus lambda for x less than 3 is equal to 4 for x is equal to 3 is continuous at x is equal to 3, then lambda is equal to and 3x minus 5 where x is greater than 3. So the options are A4, B3, C2 and D1. So by the definition of continuity, we know that limit of x tends to 3 positive f of x is equal to f of 3 is equal to limit of x tends to 3 negative f of x. So therefore we can write limit of x tends to 3 minus f of x equals 4, or limit of h tends to 0, 3 minus h plus lambda is equal to 4. Now that gives us 3 plus lambda is equal to 4. Therefore, taking 3 on the right hand side, we can say lambda is equal to 1, which is option D. For the function f of x is equal to limit of n tends to infinity log of 2 plus x minus x to n sin x upon 1 plus x raised to 2n, which of the following is true? A. Limit of x tends to 1 negative f of x does not exist. B. Limit of x tends to 1 positive f of x does not exist. C. Both limits exist and limit of x tends to 1 negative of f of x is equal to limit of x tends to 1 positive f of x. D. Both limits exist and limit of x tends to 1 negative f of x is not equal to limit of x tends to 1 positive f of x. So first we write f of x is equal to limit of n tends to infinity log of 2 plus x minus x raised to 2n sin x upon 1 plus x raised to 2n. Now that from that we can write f of 1 is equal to limit of n tends to infinity log 3 minus sin 1 upon 2, which is equal to 1 by 2 log of 3 minus sin 1. Now we can say limit of n tends to infinity x raised to 2n is equal to 0 if x square is less than 1 and it's infinity for x square greater than 1. So now for x square less than 1, f of x is equal to limit of n tends to infinity log of 2 plus x minus x raised to 2n sin x upon 1 plus x raised to 2n, that is equal to log of 2 plus x. And for x square greater than 1, we can say f of x is equal to limit of n tends to infinity log of 2 plus x upon x raised to 2n upon 1 plus 1 upon x raised to 2n, which is equal to minus of sin x. So now we can write f of x equals log of 2 plus x for x square less than 1, 1 by 2 log 3 minus sin x minus sin 1 for x is equal to 1 and minus sin x for x square greater than 1. Now therefore we can write limit of x tends to 1 in the negative f of x equals limit of h tends to 0 minus sine of 1 plus h equals log of 3, and the limit of x tends to 1 on the positive, f of x equals limit of h tends to 0 minus sine of 1 plus h, which is equal to minus sine 1. Therefore, we can say clearly both limits exist and they are not equal to each other. Therefore, the answer is option D. The function f of x is equal to 2x square plus 7 upon x cube plus 3x square minus x minus 3 is discontinuous for a x is equal to 1 only, b x is equal to 1 and x is equal to minus 1 only, c x is equal to 1, x is equal to minus 1, x is equal to minus 3 only, and d x is equal to 1, minus 1, minus 3 and other values of x. So therefore we have f of x is equal to 2x square plus 7 upon x square into x plus 3 minus 1 into x plus 3, which is equal to x square 2x square plus 7 upon x square minus 1 into x plus 3. So therefore it's equal to 2x square plus 7 upon x minus 1 into x plus 1 into x plus 3. Hence the points of discontinuity can be written as x is equal to 1, x is equal to minus 1 and x is equal to minus 3 only, which is option C. Let f of x is equal to x minus 4 upon mod of x minus 4 plus a for x less than 4 is equal to a plus b for x is equal to 4, and x minus 4 is upon x mod of x minus 4 plus b for x greater than 4. Then f of x is continuous at x of x is equal to 4 when a is equal to 0, b is equal to 0, a is equal to 1, b is equal to 1, c a is equal to minus 1, b is equal to 1, or d a is equal to 1, b is equal to minus 1. So first we write limit of x tends to 4 minus f of x equals limit of h tends to 0 f of 4 minus h, that is limit of h tends to 0 4 minus h minus 4 upon mod of 4 minus h minus 4 plus a, which is equal to limit of h tends to 0 minus h by h plus a, which is equal to a minus 1. So next we do for the limit x tends to 4 positive f of x is equal to limit of h tends to 0 f of 4 plus h, which gives us limit of 4 plus h minus 4 upon 4 plus h minus 4 mod plus b, and the other limit of h tends to 0. Now this gives us b plus 1, and therefore we can write f of 4 is equal to a plus b. Since f of x is continuous at x is equal to 4, therefore we can say limit of x tends to 4 minus f of x is equal to f of 4 is equal to limit of x tends to 4 positive f of x, and we can write a plus b is equal to a minus 1 is equal to b plus 1. Therefore we get b is equal to minus 1 and a is equal to 1, which is option D. the value of f of 0 so that the function f of x 27 minus 2x raised to 1 by 3 minus 3 upon 9 minus 3 24 243 plus 5x raised to 1 by 5 where x is not equal to 0 is continuous is given by a 2 by 3 b 6 c 2 or d 4. So therefore, since f of x is continuous at x is equal to 0, therefore we can write f of 0 is equal to limit of x tends to 0, f of x limit which is equal to limit of x tends to 0, 27 minus 2x raised to 1 by 3 minus 3 upon 9 minus 3 into 243 plus 5x raised to 1 by 5. Now this is in 0 by 0 form, so therefore we can write limit of x tends to 0, 1 by 3, 27 minus 2x raised to minus 2 by 3 into minus 2 upon minus 3 by 5 into 243 plus 5x raised to minus 4 by 5 into 5, which gives us 2, which is option C. If the function f of x is equal 1 plus sine pi x by 2 for minus infinity less than x less than equal to 1, ax plus b for 1 less than x less than 3, 6 tan x pi by 12 for 3 less than equal to x less than 6 is continuous in the interval of minus infinity to 6, then the values of a and b are respectively a 0, 2, b 1, 1, c 2, 0 or d 2, 1. The given function is continuous at all points from minus infinity to 6, and at x is equal to 1 and x is equal to 3 the function is continuous. So therefore we can write limit of x tends to 1 minus f of x is equal to limit of x tends to 1 on the positive f of x, that gives us 1 plus sine x sine pi by 2, which is can be written as a plus b, and therefore from this we can write a plus b is equal to 2. Now if at x is equal to 3 the function is continuous, then the limit of x tends to 3 minus f of 3 is equal to limit of x tends to 3 positive f of x, giving us 3a plus b is equal to 6. So from this we know a, from both these equations we could equate a to be 2 and b to be 0, which is option C. If f of x is equal to x sine 1 by x for x is not equal to 0 and k for x is equal to 0 is continuous at x is equal to 0, then the value of k is a1, b minus 1, c0 or d2. So if f of x is continuous at x of 0, then we can write f of 0 is equal to limit of x tends to 0 of f of x. Now given is f of 0 is equal to k. So from this we can write f of 0 is equal to k is equal to limit of x tends to 0 x of sine of 1 by x. So we could say f of 0 is equal to k is equal to 0, as minus 1 less than sine of 1 by x is less than equal to 1. So therefore we can say k is equal to 0. That is option C. if f of x is equal to sine of x upon x plus 1 for x greater than 0, cos of pi by 2 of x for x less than 0, this upon x, where x denotes the k at x is equal to 0, the greatest integer less than equal to x, then in the order then f b, continuous at x is equal to 0, the value of k is a equal to 0, b equal to 1, c equal to -1, or d indeterminate. So first we have f is continuous at x is equal to 0. So from that we can write limit of x tends to 0 negative f of x is equal to limit of x tends to 0 positive f of x is equal to f of 0. From this we can write limit of x tends to 0 negative f of x is equal to f of 0. Now k is equal to limit of h is equal to 0, f of 0 minus h is equal to limit of h tends to 0 cos of pi by 2 into 0 minus h upon 0 minus h. This gives us limit of h tends to 0 cos of pi by 2 minus h upon minus h. So that gives us limit of h is equal to 0 cos of minus pi by 2 upon minus 1. So therefore we can say k is equal to 0, which is option A. The values of a and b is such that the function minus 2 sine x, where x is less than equal to minus pi by 2, a sine x plus b for minus pi by 2, and cos x where x is greater than equal to pi by 2 is continuous everywhere for a is equal to 0, b is equal to 1, a is equal to 1, b is equal to 1, c a is equal to -1, b is equal to 1, or d a is equal to -1 and b is equal to 0. So for all continuity at x where x belongs to R, we must have f of minus pi by 2 equals limit of x tends to minus pi by 2 on the negative minus 2 sine x equals limit of x tends to pi by minus pi by 2 on the positive a sine x plus b. So from this we know it is equal to 2 is equal to minus a plus b. Now f of pi by 2 is equal to limit of x tends to minus pi by 2 on the negative side, giving us a sine x plus b, which is equal to limit of x tends to pi by 2 minus pi by 2 on the positive side of cos x. These both are taken on my x tends to positive pi by 2. So which is equal to, we could say 0 is equal to a plus b. So from these both equations stated as 1 and 2, we can write a is equal to -1 and b is equal to 1, which is option C. In order that the function f of x is equal to x plus 1 raised to cot x is continuous at x is equal to 0, then f of 0 must be defined as a f of 0 is equal to 1 by 3, b f of 0 is equal to 0, c f of 0 is equal to e, or d none of these. So for continuity at x is equal to 0, we must have f of 0 is equal to limit of x tends to 0, f of x is equal to limit of x tends to 0, x plus 1 raised to cot x. That gives us limit of x tends to 0, 1 plus x raised to 1 by x, that raised to x cot x. That equates back to cot x. So that gives us limit of x tends to 0, 1 plus x raised to 1 by x, that raised to limit of x tends to 0, x by tan x. So that could be written as e raised to 1 or e, which is option C. If f is r tends to r is defined by f of x is equal to cos of 3x minus cos x upon x cube for x is not equal to 0 and lambda for x is equal to 0, and if f is continuous at x is equal to 0, then lambda is equal to a minus 2, b minus 4, c minus 6 or d minus 8. So given that f of x is equal to lambda for x is equal to 0, we could write NHL as limit of x tends to 0 minus, on the left hand side, f of x is equal to limit of h tends to 0 cos of 3 0 minus h minus cos of 0 minus h upon 0 minus h the whole square. That gives us limit of h tends to 0 minus 9 cos 3h plus cos h upon 2. By using L'Hopital's rule, we could now write this equals minus 9 plus 1 by 2, which is equal to minus 4. So from this we could say limit x tends to 0, negative left hand side, f of x is equal to f of 0. Therefore f of x is continuous at 0. Now from this we could write minus 4 is equal to lambda, or lambda is equal to minus 4. That is option B. Function f of x is equal to 1 minus cos 4x upon 8x square, where x is not equal to 0 and f of x is equal to k, where x is equal to 0 is continuous function at x is equal to 0, then the value of k will be a, k is equal to 0, b 1, c minus 1 or d none of these. So from this we know if f of x is continuous at the point x is equal to 0, then limit of x tends to 0 positive from the right hand side, f of x is equal to limit of x tends to 0 negative on the left hand side, f of x equals limit of h tends to 0 to sine square 2h upon 8h square, which is equals limit of h tends to 0 sine square 2h upon 4h square. Now we could write limit of h tends to 0 sine 2h by 2h the whole square is equal to 1. Then limit of x tends to 0 negative f of x is equal to limit of h tends to 0 f of 0 minus h equals limit of h tends to 0 f of minus h equals limit of h tends to 0 1 minus cos 4 of minus h upon 8 into minus h the whole square. That gives us limit of h tends to 0 1 minus cos 4h upon 8h square is equal to 1. So therefore we can say if f of 0 is equal to 1, k is also equal to 1, which is option B.
Question 15. If f of x is equal to 1 minus sin x upon pi minus 2x, where x is not equal to pi by 2, lambda x is equal to pi by 2, b, continuous at x is equal to pi by 2, the value of lambda is, we give 4 options. f of x is continuous at x is equal to pi by 2, then limit x approaches to pi by 2 of f of x is equal to f of pi by 2, or we can say lambda is equal to limit x approaches to pi by 2 1 minus sin x upon pi minus 2x, which is of 0 upon 0 form. So we apply L'Hospital's rule, we get lambda equal to limit x approaches to pi by 2 minus cos x upon minus 2, which we get lambda equal to limit x approaches to pi by 2 cos x by 2 equal to 0, which is, if we see, our answer matches with option C. Therefore option C is the correct answer. If f of x is equal to 2 minus root x plus 4 upon sine 2x, where x is not equal to 0, as continuous function at x is equal to 0, then f of 0 equal to, we give 4 option. F of x is continuous at x is equal to 0, then f of 0 equal to limit x approaches to 0. F of x is equal to limit x approaches to 0, 2 minus root x plus 4 upon sine 2x, which is in the form of 0, 0. So we use 0 upon 0 form. So we use L'Hospital's rule, we get f of 0 equal to limit approaches to 0 minus 1 by 2 root x plus 4 upon 2 cos 2x, which is equal to minus 1 by 8, which is, our option matches with D. Therefore D is the correct answer. Question 17. The function defined by f of x is equal to x square plus e square raised to 1 by x raised to minus 1, where x is not equal to 2. K x is equal to is continuous from right at the point x is equal to, then k is equal to, we're given 4 options. We have for f of x equal to x square plus e raised to 2 minus x, so minus 1, and f of 2 equal to k. If f of x is continuous from right at x is equal to 2, then limit x approaches to 2 from the right hand side of fx is equal to f of 2, which is equal to k. Therefore limit x approaches to 2 from the right hand side, x square plus e 1 upon 2 minus x raised to minus 1 equal to k. Therefore we get k equal to limit h approaches to 0, 2 plus h, that is f of 2 plus h. We get k equal to limit h approaches to 0, 2 plus h the whole square plus e raised to 1 by 2 minus 2 plus h raised to minus 1. We get k equal to limit h approaches to 0, 4 plus h square plus 4h plus e raised to minus 1 by h, so minus 1, where we get k equal to 4 plus 0 plus e raised to minus infinity raised to minus 1, where we get k equal to 1 by 4, which is, we see our answer matches with B. Therefore B is the correct answer. The value of f of 0, so that the function f of x is equal to root of a square minus ax plus x square minus root a square plus x square ax plus x square upon root a plus x minus root a minus x becomes continuous for all x as given by. F of x is continuous for all x, so it is continuous at x is equal to 0. So for f of 0 equal to limit x approaches to 0 of f of x, so we can write this as limit x approaches to 0 under root a square minus ax plus x square minus a square plus ax plus of x square upon a plus x minus a minus x. Limit x approaches to 0 minus 2ax upon 2x into limit x approaches to 0 a plus x, so a minus x under root of a square minus ax plus of x square plus a square plus ax plus of x square, where we can write this as minus a into 2 root a 2a. We're left with minus root a, which is, if we see we can write this as minus a raised to half, which option C is the correct answer. Question 19, the function f of x is equal to 1 minus sin x plus cos x upon 1 plus sin x plus cos x is not defined at x is equal to pi. The value of f of pi so that the f of x is continuous at x is equal to pi is, we give 4 options. We make a fine adjustment in the numerator and the denominator. We can write that as f of x is equal to 2 cos square x by 2 minus 2 sin x by 2 cos x by 2 upon 2 cos square x by 2 plus 2 sin x by 2 cos x by 2 which can be written as cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2. Therefore, this can be written as tan pi by 4 minus x by 2. Further, at x is equal to pi, we get f of pi is equal to minus tan pi by 4, which is equal to minus 1, which is our option C. Therefore, option C is the correct answer. Question 20. If f of x 1 minus mod x upon 1 plus x is not equal to minus 1, where x is equal to minus 1, then the value of f of 2x will be where bracket shows the greatest integer function. So we have function for f of x for x is equal to not equal to minus 1 and x is equal to minus 1. For f of 2x, we can write this as 1 for x less than 0, 1 minus 2x, 1 plus 2x for x greater than 0, where f of 2x equal to will be 1 x less than 0, 1 x greater than equal to 0 or less than half, or 0 where x greater than equal to half, less than 1, less than equal to 1, and for minus 1 by 3 we can write x greater than equal to 1 or less than 3 by 2. So where bracket greatest integer function for f of x for all values of x where x is less than half, continuous function, and for x is equal to half and x is equal to 1, f of x be the discontinuous function. So answer D, if we say that is all of that is continuous at x is equal to minus 1, continuous at x is equal to 0, and discontinuous at x is equal to half. Therefore D is the correct answer, that is all of the above. Question 21. If the function f of x is equal to 2x minus sine inverse x upon 2x plus tan inverse x, where x is not equal to 0, is continuous at each point of its domain, then the value of f of 0 is, we are given 4 options. If you see the function, it is in the 0 upon 0 form. So applying the L'Hospital's rule for f of 0 equal to limit x approaches to 0, 2 minus under root 1 plus 1 minus x square upon 2 plus 1 upon under root 1 plus x square. For the solving, we get 2 minus 1 upon 2 plus 1 equal to 1 by 3, which is, you see, option B is the correct answer. Question 22. The value of f at x is equal to 0 so that the function f of x is equal to 2 raised to x minus 2 raised to minus x upon x, where x is not equal to 0, is continuous at x is equal to 0, is, again, 5 options in this. For f of 0 equal to limit x approaches to 0 of f of x is equal to, you get limit x approaches to 0 2 raised to x minus 2 raised to minus x upon x. For solving this, we can write this as limit x approaches to 0, 2 raised to x plus of 2 raised to minus x log to the base e 2 upon 1. Further, we get as 2 raised to 0 plus 2 raised to 0 log to the base e 2, which we get 1 plus 1 log to the base e 2, which we get 2 log to the base e. Final answer we get as log to the base e 4, which is our option we see, that is E. Therefore, option E is the correct answer. Question 23. If f of x equal to 2x, x less than 0, 2x plus 1, which is x greater than or equal to 0, then we're given 4 options. Taking LHL, that is left hand limit, equal to limit x approaches to 0 from the left hand side of f of x is equal to, we get limit x approaches to 0 from the left hand side at 2x is equal to 0. RHL equal to limit x approaches to 0 from the right hand side of f of x is equal to, we get as limit x approaches to 0 right hand side 2x plus 1 equal to 1. Therefore, we see left hand side and right hand side is not equal to 0. Therefore, f of x is discontinuous at x is equal to 0, which is, if we see, our option C is the correct answer. Question 24. If f r belongs to R is defined by f of x is equal to x minus 3 plus mod x minus 4 for x belongs to R, the limit x approaches to 3 from the left hand side of f of x is equal to, we're given 4 options. Given that f of x is equal to x minus 3 plus of mod x minus 4, limit x approaches to 3 from the left hand side of f of x equal to limit x approaches to 3, we get x minus of 3 plus of mod x minus 4. Further, we can either limit h approaches to 0, we get 3 minus h minus 3 plus of h 3 minus h minus 4 mod. For the solving, we can write the limit h approaches to 0, we get minus h plus of 1 plus h, which is equal to minus 1 plus 1 plus 0, which we get as equal to 0. Therefore, value C, that option C, is the correct answer. Question 25. F of x is equal to x into x raised to 5, where x less than 0 is continuous, 2a plus x with x greater than 0. At x is equal to 0, then a equal to, we are given 4 options. For continuity at x is equal to 0, limit x approaches to 0 from the left hand side should be equal to limit x approaches to 0 from the right hand side equal to f of 0. Further, for left hand limit x approaches to 0, for x we get as limit x approaches to 0, which we get as 0. For limit x approaches from the right hand side, to a plus x, which we get as equal to 2a. So let this, so by this we get that 0 equal to 2a, where we get the value of a is equal to 0. Therefore, option B is the correct answer. 26. If the function f of x is equal to x square minus a plus 2 into x plus a upon x minus 2 for x not equal to 2, and for 2 for x is equal to 2 is continuous at x is equal to 2, then we are given 4 options. F of x be the continuous at x is equal to 2, then limit x approaches to 2 of f of x is equal to f of 2 equal to 2. Therefore, that is limit x approaches to 2 x square minus a plus 2 into x plus a upon x minus 2 equal to 2. So therefore left hand side must be 0 upon 0 form. So using L'Hospital's rule, we have limit x approaches to 2 to x minus a plus 2 upon 1, which is equal to 2. Therefore we get 4 minus a minus 2 equal to 2, where we get a is equal to 0. Therefore option A is the correct answer. Question 27. F of x is equal to x plus minus x when x is not equal to 2, lambda when x is equal to 0. If f of x is continuous at x is equal to 2, then the value of lambda will be, we give 4 options. F of x is continuous at x is equal to 2, therefore limit x approaches to 2 of fx equal to f of 2 equal to lambda. Therefore lambda equal to limit x approaches to 2 f of x equal to limit x approaches to 2 x plus of minus x. Further solving, we get limit h approaches to 2, right, 2 plus of h plus of minus 2 plus of h. Further, we get 2 plus minus of 3, which is equal to minus 1, which answer matches with option A. Therefore option A is the correct answer. F of x is equal to x sine pi by x is continuous at everywhere, then f of 0 is equal to f of x is continuous everywhere, so we write limit x approaches to 0 of f of x is equal to f of 0. Therefore limit x approaches to 0 x sine pi by x is equal to f of 0. For 0, oscillating function between minus 1 and 1 equal to 0. Therefore f of 0 is equal to 0. Therefore we see option C is the correct answer. The value of f of 0 so that the function f of x is equal to 1 minus cos x upon x raised to 4 is continuous everywhere is given 4 options. Limit x approaches to 0 1 minus cos bracket 1 minus cos x upon x raised to 4 equal to limit x approaches to 0 get 2 sine square upon, we can write it as, we can write this function as equal to limit x approaches to 0 2 sine square upon 2 sine square x by 2 upon 2 upon x raised to 4. Therefore limit x approaches to 0 2 sine square x by 2 sine square x by 2 the whole square upon x raised to 4 sine square x by 2 the whole square. We get this as equal to 2 limit x approaches to 0 sine raised to 4 x by 2 upon x by 2 the raised to 4 into 2 raised to 4, which is equal to, we get as 1 upon 2 raised to 3, which is equal to 1 by 8, which is our option D. Therefore option D is the correct answer. The values of a and b such that the function defined by f of x for 7 x is less than equal to 2 ax plus b, where x greater than 2 or less than equal to 9, and 21 for x greater than equal to 9 is continuous function are given 4 options. For limit x approaches for 2 from the left hand side of fx, we get as 7, and limit x approaches to 2 from the right hand side, we get f of x is equal to ax plus b, which is equal to 2a plus of b. Since f of x is continuous at x is equal to 2, therefore limit x approaches to 2 from the left hand side of fx is equal to limit x approaches to, so this is the right hand side to the left hand side of fx. So we get 2a plus b equal to 7. So similarly, limit x approaches to 9 from the left hand side of fx equal to 9a plus b, same as limit x approaches to 9 plus f of x is equal to 21. So for f of x is continuous and x is equal to 9, so this both can be equal to each other, so this can be as 9a plus b equal to 21. Therefore, solving both, this as equation 2 and this as equation 1, solving 1 and 2, we get a equal to 2 and b equal to 3, which is our option. We see option B is the correct answer.